Welcome to the Explainer. Today, we're going to pull back the curtain on a piece of tech that's quietly running the world. I'm talking about Apache Kafka. It's the engine behind your ride-sharing app, your bank's fraud detection, you name it. So let's kick things off with a huge question. How do you possibly process millions, literally millions of messages every single second in real time? Think about it. All those website clicks, all those sensor readings from IoT devices, stock trades flying by, it's a fire hose of data. Well, that exact problem is why Kafka exists. All right, so here's our game plan. We're going to see what's happening under the hood. To do that, we are going to follow the journey of just one single message, from the second it's born all the way to when it gets read, and we'll unpack every single piece of the puzzle as we go. All right, first things first. What is Apache Kafka? Let's just dive right in. The absolute best way to get your head around it is with a really simple but powerful analogy. Think of it like a super efficient, high-tech post office, but built just for data. So what does that mean, a data post office? Well, at its heart, Kafka is what we call a distributed streaming platform. It's this central hub, right? You have applications called producers that send streams of data to the hub, and then you have other applications called consumers that come and pick that data up. Kafka is that reliable middleman making sure every piece of mail gets where it's going. But why is it so popular? I mean, it's everywhere. It really comes down to a few killer features. First, it is ridiculously fast. We're talking real-time speed. Second, it's incredibly fault-tolerant. Your data gets copied across multiple servers and written to disk, so it's not just going to disappear. And maybe most importantly, it decouples your systems. The sender doesn't need to know a thing about the receiver and vice versa. That makes your whole setup way more flexible and easier to manage. Okay, so let's start that journey we talked about. We're going to begin right at the source, the moment a message is created. And that brings us to the producer. So what's a producer? Its job is actually super simple, but it's absolutely vital. A producer is just any application that needs to send or publish data into Kafka. It could be your web server logging user clicks. It could be a tiny IoT device reporting the temperature. All it does, its only job, is to wrap up a piece of info and drop it in the mail, sending it off to our data post office. On the actual process, it's a pretty simple 1, 2, 3. First, the producer creates a record. You can think of this like putting your letter in an envelope and writing the address on it. Second, it sends that record over to the Kafka cluster. And third, it gets an acknowledgement back. We call it an ACK, which is basically a delivery receipt saying, yep, we got it. Okay, now this next part is super important, especially if you're building a mission-critical system. Kafka gives you, the developer, direct control over reliability with this one setting called ACKs. If you set ACKs equals 0, it's fire and forget. You just toss the message over the wall and hope for the best. It's the fastest, but yeah, you could lose data. The default is ACKs equals 1, which is a pretty good balance of speed and safety. But if you're dealing with something like financial transactions where losing even one message is a disaster, you use ACKs equals all. This is the Fort Knox option. It's a bit slower, but it gives you an ironclad guarantee that your data is safe. So, our message is sent. It's zipping across the network and arriving at the Kafka cluster. Now, let's follow it inside and see how this high-tech post office actually works. Right, so the cluster is just a group of servers working together. Each individual server in that group is called a broker. You can think of a broker as one of the postal workers, or maybe a single branch of the post office. Now, you could run Kafka with just one broker, but you really wouldn't want to. The real magic happens when you have a bunch of them working together as a team. And this is where Kafka's design for fault tolerance really shines. It's genius, really. For any given piece of data, one broker is designated the leader. It does all the heavy lifting, all the reads and writes. The other brokers are followers. Their only job is to sit back and make perfect copies of what the leader is doing. Now, what happens if that leader server crashes? No problem. One of the followers is instantly promoted to become the new leader. The whole system just keeps running without a hiccup. It's seamless. So, messages don't just get dumped into a big pile inside the cluster. That would be chaos. Instead, they're organized into categories called topics. A topic is just a named stream of messages. Think of it like a specific mailbox at the post office. You might have a topic for user signups, another one for payment transactions. It's all about keeping things organized. And here it is. This is the secret sauce to Kafka's insane scalability.
To handle a huge volume of messages, every topic is broken down into one or more logs called partitions. The supermarket analogy here is perfect. The topic is the entire checkout area, and each partition is a single checkout lane. The more lanes you have open, the more customers you can serve at the same time, right? That's exactly how Kafka gets its massive parallelism.
Okay, but wait a minute. This whole parallel lanes thing brings up a really important question. If you have messages going into all these different lanes, how on earth do you guarantee that related messages get processed in the right order? Like making sure a create account event for a user happens before their add to cart event.
The answer is elegant: the message key. If a message doesn't have a key, Kafka doesn't care. It just spreads them out evenly, round-robin style, across all the partitions. But if you give a message a key, like, say, the user ID, Kafka makes a promise. It guarantees that all messages with that exact same key will always go to the exact same partition. And that, right there, is how you preserve order for a specific user or entity.
All right, our message has made it. It was produced, sent to the cluster, and is now sitting safely inside a partition. So, what's next? It's time for the final leg of the journey. How does this message actually get read?
The application that reads the messages is, you guessed it, a consumer. But here's the cool part. Consumers rarely work alone. They team up in what are called consumer groups. Kafka is smart enough to look at all the partitions for a topic and divide them up among the consumers in a group. This means if you need to process messages faster, you just add more consumers to the group. Kafka automatically rebalances the workload for you. It's another key to its scalability.
So how does the consumer keep track of which messages it has already read? It uses something called an offset. The bookmark analogy is perfect here. Think of a partition as a long book. Each message in that book has a unique, sequential number. That's the offset. The consumer simply remembers the offset of the last message it read. So if it crashes and comes back online, it just looks at its bookmark and starts reading from the exact right spot. No missed messages, no rereading. And again, just like we saw with the producer's ACK setting, Kafka gives developers precise control. You can let the consumer commit its offset automatically in the background. It's easy, set it and forget it. But for those really critical systems, you can switch to manual commits. This means your code is responsible for telling Kafka, okay, I have successfully processed this message, now you can move the bookmark. It's more work, but it gives you the power to build systems with guarantees like at least once or even exactly once processing. So we've seen the whole life cycle of a message, from producer to consumer. But, that's really just scratching the surface. There's a reason people call Kafka a streaming platform and not just a message queue. And that reason is its powerful set of core APIs.
We've really been talking about the producer and consumer APIs this whole time, right? The ones for sending and receiving data. But check this out. The Streams API lets you build applications that process and transform data in real time as it's flowing through Kafka. Then there's the Connect API, which is a game changer for getting data in and out of other systems, like your databases. And finally, the Admin API gives you the keys to the kingdom, letting you manage the whole cluster programmatically.
And that really wraps it up. At the end of the day, Kafka is so much more than just a pipe for sending messages. It's a complete foundation for building modern, real-time event-driven applications. It's a powerful toolkit. So the final thought I'll leave you with is, what will you build on it?